we're interested to see if we manage to break it. One thing is we're going to record this webinar because a lot of people wanted to join who couldn't at this hour, so they asked us to record it, and we'll upload the webinar on our YouTube channel in case you want to rewatch it or reshare it after this. And then in terms of kind of the rules, if you have any questions as we're going through the presentation and the content that we're going to show, you can either raise your hand. So there's a hand in the icons of Google Meet. So you can either do that, and then we can you can ask the question out loud, or you can post a question in the chat, and we'll collect the questions for the end of the presentation, where we'll try to answer as many as possible. And if we don't manage to answer any questions, we'll leave our email, and you can, of course, send the questions in an email, and we're happy to address them. And with that, maybe I'll do a short introduction about myself and then about what 2050 Materials actually is. So first of all, my name is Fanos. I'm one of the co-founders of 2050 Materials, and I come from a sustainability background. So I've been working a lot with life cycle assessments and data around all kinds of systems. So from companies to products to anything that can be quantified in terms of its impact to the environment. And 2050 Materials is a company that bridges the gap between ESG targets that are happening on a client level, a national level, a global level, with the practitioners that are designing and building in the architecture and construction sector. And that's a bit of a fancy way of saying we need to do a lot, essentially, to align with climate targets globally, and the construction sector is a huge part of that. And all that we are trying to do at 2050 is make it easy for the stakeholders in the construction sector to actually access the data they need and access the tools in order to actually limit the impacts of climate change. Now, for this webinar, we'll go through a couple of things. So we'll start by talking about the responsibility of a designer in a changing environment and in a climate change environment. And then we'll define a little bit what climate neutrality actually means for us and what we hear clients in the construction sector asking for. And then we'll dive a bit deeper into strategies of material efficiencies. So different kind of things that you can consider as a strategy in order to make your project as material efficient as possible. And we'll talk about what actually that means in terms of impact, if a designer or if an architect actually does these sort of strategies. And then at the end, we'll give a list of resources and show a couple of the tools and resources, especially the tools that we've been working on. But we'll, of course, as I mentioned at the beginning, this is being recorded. So all of this information will be posted on YouTube. And also you can, of course, reach out to us if you would like to have access to some of it that are not available online. So I would begin with that. So I would say the first thing we thought about kind of introducing when we were considering doing this webinar was to answer the question of what is the responsibility of a designer or an architect in an environment where there's global climate change targets and global demand to reduce emissions. Now, this is a little bit of a subjective opinion, I would say, but we think that a design that doesn't consider sustainability and sustainable materials is starting to become outdated. And there's three primary reasons for that. One is regulations are actually moving towards a direction where sustainability and embodied carbon specifically is really a key consideration. So we're seeing countries like the Scandinavian countries really having already regulation, as well as France. But we're also seeing the UK and some places in the US where this is starting to really become a thing. Now, the second reason, and I see there's already some manufacturers as part of the call, is that there's amazing innovation happening on the material level. That's also a big motivator for us at 2050 Materials. We have this really cool job of being able to talk to every single new company that's creating a building product, whether that's healthier paint on the walls or upcycled materials into all kinds of use cases for building. So there is a lot of materials out there that can be considered alternative to what we've been building, and it's really important to start considering them as a designer. And then finally, what we would classify as green design. So essentially, if your client is mentioning the words sustainability and wants to know more about the sustainability of the project, this is something that with the clients we work with, we are seeing expanding day by day. So even offices that a year ago were talking to clients and they were telling us our clients never ask us about sustainability, it's really a completely different picture this year. So there's a lot more people talking about the topic, asking questions, asking for metrics. So it's really something that you kind of need to start doing as a designer. Now, this is an obvious slide. We know that emissions rise every year from 1995 to 2015. We went from 5 gigatons of emissions due to materials to 11.5 gigatons of emissions. Now, that's huge, and a big part of that is metals, concrete, cement, plastics, all of the kind of obvious materials that you would think. However, it's important, and we're going to show this in a couple of slides, it's important to think about the impact of your project as a designer, no matter what project you're building. So it doesn't matter if you are a structural engineer or an interior designer, you should always take into account the impact of your project, specifically because lower impact projects like interior design projects usually have a shorter time span. So across the years, we are still creating a lot of emissions through our projects, and we can actually reduce those emissions. Now, just to give an indication of the scale of the requirements to do this, there's this amazing piece of work by a Danish group of researchers and industry leaders, which have shown that in order to stay within planetary boundaries, we need to reduce our emissions, our embodied carbon emissions, by 96% in the next 10 years. So in a Danish sense, that means go from 480 kilograms of CO2 per meter squared of area of a building down to 20. And for anyone who's an architect in here who has done embodied carbon assessments, this is a very, very challenging task, but it just goes to show how important it is that we already start moving towards this direction. Otherwise, these kind of targets will not really be met. Now, besides overall emissions of a building, it's important to consider that, as I mentioned earlier, depending on the project type, some project types like fit outs of commercial projects. So for example, if you're setting up the office for a client and you're doing the interior and fit out aspect of the project, even though it seems like it's a minimal aspect in terms of the emissions of the entire building, because we change the fit out of commercial projects between every 2.5 years to around 9 years, the emissions of all of the material that's put there, then wasted and then redone again, is actually can end up being 4 times as high as the rest of the building. Now, we talked already about climate neutrality, and it's important, I think, to define these kind of terms. And the disclaimer here is that there is probably no clear definition, but we can give you what we consider to be the definition of climate neutrality. And then even more importantly, we have a few metrics that are being asked for by clients, which are important to note as a designer. So first of all, the definition of climate neutrality. So climate neutrality, especially in the built environment, so in the construction sector, for us refers to designing, building, and then operating either buildings or infrastructure in a way that overall it doesn't contribute to the overall warming of the planet or the state of climate change of the planet. So it's kind of defining it at a level where we're simply not adding to the problem of doing that. And there's a few measures and ways to do that. The typical measures that we've been looking at throughout the years to stay climate neutral is to either make our buildings more efficient, so energy efficiency measures like better insulation, and making sure that buildings don't need to use as much energy. Then the second thing is, if we can, then we transition to renewable energy sources. So anything from installing solar panels on a building to just getting renewable energy from the grid. And then something that is more and more relevant to the construction sector in the last couple of years, and is of course a big part of what we do at 2050 Materials, is to start looking at low carbon alternatives and low impact materials, which can be specified and used in buildings so that the overall footprint of the building gets reduced. And then the last two, so the fourth point here is the reuse and repurpose. So essentially making our buildings and our processes more circular. This is massively important. That's the way forward that we'll be able to not have to extract more raw resources. And then as a last measure, we put carbon offsetting here. Technically, of course, we know carbon offsetting is one way to reduce emissions, but our view at 2050 is that that should be the last resort, especially for the built environment, because there's a lot more things you can do before you need to start offsetting emissions. Now, in terms of what we hear from the people we work with, their clients are asking for, there's a few different KPIs and metrics that are being asked to be tracked. And I'm not going to go through the whole list here. This is something that you can take a look when we upload the video, or take a screenshot now. It's something that I think is a useful list even when discussing with new clients. But generally, especially because carbon is a lot at the forefront, when we're talking about energy efficiency, the metric that generally is being tracked is the operational emissions of the building every year. And that's usually normalized on the area, on the gross internal area of the building. And then in terms of low embodied carbon, then we are tracking the embodied carbon of the building, again, per area and per year of the building. And for those of you that might not be aware with the technical terms of embodied carbon, that refers to all of the emissions that are related to the materials of the building, which takes into account anything in terms of resource extraction when the manufacturer wants to create the material, to transporting that material to the site, to eventually throwing it or recycling it. Now, because we show all of these kind of very quantitative data points and quantitative metrics, it kind of brings the question of, does every designer really need to become a specialist in sustainability? And does everyone need to understand all of these parameters? And this is really a big part of why we exist as 2050 Materials. Our opinion is really, the answer to this question is always no. So we think that if all of us need to become sustainability specialists, then we have very little chances as a sector to achieve the climate targets that we've put. However, having said that, some familiarity and learning is still needed in the space. So some key topics to kind of be familiar with is, what is the industry doing, and are there any benchmarks or best practices in the type of project I'm working on? Then in terms of materiality, what does it mean when we talk about sustainable materials? There's a lot of marketing and lingo and even greenwashing in this space, where things are being classified as sustainable. And I think it's important as a designer to look at what are factors that can actually define sustainability and what are the parameters to consider. And then finally, and this is very important in terms of practicality, and we are very practical at 2050 Materials, is we talk a lot about the theory and the theoretical metrics we should be looking at, but the real question often comes to, where can I actually find that information, and how can I use it in my design process, in my specification process, in my procurement and supply chain processes. Now, in terms of resource efficiency and climate change, there's a lot of different frameworks that you can apply in the built environment to actually reduce your impacts to the planet and reach climate targets. We unfortunately only have an hour for this webinar, so what we are going to do is focus on the material efficiency. But when we post this video, we'll post also links of some of the reports we've researched throughout our work in order to be able to dive into the other topics as well, if you're interested. Okay, so let's dive a little bit into the material efficiency strategies. So this is a little bit of a call to action for anyone who is a climate conscious designer, which I think most people who have joined the call and are designers probably fall within that category. Now, there's 7 strategies that are identified as material efficiency strategies for climate action, and we'll take them one by one, explaining what before kind of diving deeper into the actual tools that exist to take action on them. So the first strategy is use less material by design. So that means if you have the possibility to design lighter structures and use lighter and smaller materials that deliver the same services, then that's always a good idea, because that usually means that you're using less resources, which often translates into less emissions. Now, the second strategy is, can I substitute some materials for other ones? And this is, for me, a really exciting one, because as I said in the beginning, there's a lot of new products out there that are really, truly more sustainable than conventional materials. And I think as designers, it's not just a necessity to start looking at those materials, but it's actually exciting, whether that's earth products, mycelium products, anything that is either a new innovative material or something that has been brought back from older types of architecture. So yes, material substitution basically involves seeing whether one of the materials that I'm currently using can be substituted for something that has less of an impact. So that might mean exchanging concrete for something like engineered wood or cross-laminated timber. It might also mean exchanging a finish in my wall for something that is lower impact and healthier to the inhabitants. Now, the third strategy is whether we're able to improve the yield of fabrication. So this is something that applies a little bit less to the designers, but it's very applicable for manufacturers. So if we are able to, as a manufacturer, to have less scrap material and less wasted material, then that means that we're generally using, again, less resources, and often that translates to less emissions. And then the fourth strategy, again, going back to the designers, is whatever you design, whether it's an office or a house or a hospital or whatever it might be, it really makes a difference if you make it very, very efficient and useful for the specific purpose that is being designed. A good kind of anecdote there is, I come from a Mediterranean culture, and often in the houses that we lived in, we have 2 living rooms, and one of them is basically never used because it's the formal one. And I think that's a prime example of design that's really not efficient and doesn't maximize the use of buildings. So one very, very important thing is build buildings that will be used, because resources that go into these projects are important, basically. Then talking a little bit about what happens at the end of life of a building, or the materials at the end. Whatever we can recycle and reuse, it's important to make sure that we minimize the impacts of the demolition sites or of anything that is being retrofitted by minimizing what goes to the landfill, and actually being able to recirculate a lot of those materials, either by reusing them or by recycling them. And the next strategy essentially is the same thing. It's a very similar aspect in the cases where we can actually reuse materials without any processing and replace anything that is using a primary product with something that has already been manufactured. That's extremely important, because that means that we don't need to build or to manufacture a new product to create whatever we're creating. And then finally, in terms of extension of lifetime, so this is, I would say, a slightly controversial strategy in the space of climate change, because if we extend the lifetimes of projects, it usually means making them sturdier, and usually that might translate into using specific materials that can last a longer amount of time. But whether or not we actually keep those structures and those projects up for the amount of time that they were intended is a little bit unknown, I would say. But generally speaking, in an ideal world where we can create buildings, for example, that after their first use case don't need to be demolished in order to build a new building that will be something else. So if I built a commercial office and then it will eventually turn into a multi-story residential building, ideally we want to avoid that the first building has been demolished in order to create the second one, and building for longevity and building for extended lifetimes can really be very efficient there. Okay, so this is, so just to go back to the slide here. So these are seven strategies for climate action with regards to material efficiency. A lot of these are somewhat theoretical, so a lot of them are kind of high level. So I would say that the next section for me is a very, very important one. It's one that personally keeps me motivated to be working on this topic. And that is, what does it actually mean as a designer if you try to do the best available option in terms of your design, in terms of picking materials, and specifically in terms of making your buildings materially efficient? And if there's any section of this presentation that I would love if people remembered, it would really be this one. The simplest way I can explain this is, without assuming any new innovations, without assuming that anything changes in the grid, just by the choices of materials that exist today in the construction sector, whether you're designing an interior design project or whether you're building an entire building, if you take correct decisions and you switch materials for lower carbon ones and you try to optimize the efficiency of your buildings, you can reduce 40% of each project's emissions. So that's a rough number from research that was done in this space. Now, globally, as an industry, we're emitting almost 4 gigatons of emissions simply due to building materials. And if every single designer and architect were to start considering these material efficiency strategies, and if everyone was achieving about 40% of emission reductions, that means that we would be avoiding 1.8 gigatons of emissions every year, which is 4% of global emissions. And it doesn't sound like much if we say 4%, but imagine if you had the entire emissions of the UK, or the entire UK not emitting emissions for a year. And now imagine having that twice and 3 times and 4 times. So if you're a designer, you have a disproportionate potential to reduce emissions versus any other profession in my opinion, at least. So it's extremely important to really start getting on this boat and start reducing emissions, because the amount of impact that you can have is really very, very large. Okay. Having said that, I would jump to the tips and the kind of cheat sheets and tools that we put together, and then continue with a small demo. Maybe for anyone who, before I jump to this, before anyone who joined a little bit later, if you have any questions, you can either write them in the chat and we'll collect the questions and have a small Q&A session in the end, or you can kind of click the raised hand and then we'll give you the microphone. Okay, so in terms of tips, I would say this is a list that, again, you don't need to remember. We'll send this over, and it's something that is a nice checklist to look through. But generally, there's a process that we've seen that when it's followed, it delivers what we think is the maximum outcome with the current technologies. And it starts from really understanding what is your client and who is your client and what do they actually need. It follows with considering where is my project and what is actually possible in the location of my project. And in that point, it's really important to start looking for examples of things that have been done in similar locations. That's often a very, very strong convincing factor also for clients, even though some clients might start by not having any sustainability targets. When you show them an example of a building that has followed best practices, it usually is a very strong convincing factor. Then as a designer, there's this responsibility to at least start coming up with concrete suggestions and specific case studies of what can be done better from the initial proposal. And then once you start going into the process of the stages of design, you can start forecasting the impacts of your design early on. And it's been shown that doing these early forecasts is the best thing you can do in terms of impact, because it allows you to understand early on what the impact of a specific decision is before you actually lock that decision into place. In the same spirit, you can compare different scenarios. So you can present a worst case scenario, a high, like a middle scenario, and a best case scenario. That usually is a very good way to convince clients as well. And then you can gather the data to see what's the easiest thing I can actually do in order to achieve a more sustainable design. And then the later design stages, once decisions have been started being locked in, you can then run more detailed assessments. There's really not a lot of point in detailed assessments early on, because in construction projects, things change a lot. And then as a designer, something that again is very, very important is, if you've come up with a design, suggestions and specific material specifications and product specifications that you've ended up with, and there's a process of value engineering during the procurement and the construction phases. As a designer, the best thing you can do is actually come prepared. So come with data and whatever necessary information you have in order to convince the contractor, for example, that these kind of materials should not be value engineered out of the project. Okay, so having said that, I would say we've put a small list together. This is by no means exhaustive, and it would be great also in the chat if you wanted to share more tools and resources that people should know about. But this is an initial list of resources that you can tap into to start, first of all, learning more about efficiency of materials and the importance of taking into account these considerations, but also actual tools where you can practically start taking steps in your projects to reduce the impact of them. So the first one is LETI, so the London Energy Transformation Initiative. This is an amazing group of industry leaders who have created publications around embodied carbon and the regulation and benchmarks around them. So we really suggest you go to the website and read the publications. Then both the UK as well as the US Green Building Council has very good resources, both on the theoretical level, so kind of what you should be doing and what is happening in the industry, but also just a library of solutions that can help you achieve specific targets. Then there's the reduction roadmap, which is the research by the Danish group that I mentioned earlier, which shows what kind of reductions we need to do in terms of emissions to stay within planetary boundaries. And then going more to toolkits, there is a great tool by Arup around circularity, where you can select specific strategies and you actually get a list of tasks to follow and a list of KPIs to report and track the performance. There's the Healthy Materials Lab, which is a lot of different things, but among which there's a library as well as a lot of documentation and courses where you can learn not just more about the carbon impacts of materials, but also the health aspects of specifying materials. And then there's groups like the Architects Climate Action Network in the UK, as well as in other countries. And specifically the one that links a lot to materials is this Natural Materials Working Group, where there's really a lot of resources to be tapped into around using bio-based materials and natural materials. And then the last two are more related to the work that we do. So as 2050 Materials, we write a lot of content. So there's a blog on our end which you can tap into that has a lot of research, both on introducing specific concepts in a rather simple way for designers to start with, as well as really deep diving into specific topics. Recently, we've written a lot about insulation materials and key parameters to consider. And then besides just the blog, there's also a lot of graphical illustrated guides that we do that help you navigate a little bit the space. Specifically, the ones I'm sharing are the ones that we've done around the insulation materials. And this is something that if you would like to have to all of these kind of posters that are informative, they're free to access on our website by just entering an email. And then finally, we have the actual tool that we've been working on for the last year. It's been a journey, to say the least. So I would like to spend a couple of minutes also showing at least some features of our tool. We probably don't have enough time to really run through everything, but I would like to kind of give a sneak peek of what we've built up to now. And then if anyone is interested in diving deeper into it, you can, of course, either do that by registering. It's free to register on app.2050materials.com, or you can just reach out to us and we can give a more elaborate demo. I'm going to have... Okay. Super. And after the demo, we can, of course, start answering questions. I've seen that some people already posted their questions. Okay. So as I said earlier, this is the main tool that we've been working on at 2050 Materials. It's accessible at app.2050materials.com. We can also post the link in the comments. There's essentially two sides to this platform I would like to show. And I think the best way to show it is assuming we have an actual project that we're working on as a designer. And I know this might not represent every designer that's on the call, but I'm just going to assume that we have an architect who's working on a high-rise residential building. And I'm going to start not from the library of materials, which I think is what probably a lot of you have seen already, but more from the tool side of things. So this is the landing page. And when you click on tools, you can go under architects and designers, and you can start by selecting what we call the embodied carbon optimizer. So under this, you have a choice of selecting different kinds of projects. So you can choose 3 types of commercial projects: high-rise, low-rise, and fit-out projects. And then you can choose residential projects, high-rise and low-rise. And these kind of typologies are something that we keep working on. So we're releasing soon also an industrial design, so something that's more like a factory, as well as specific assemblies and systems that you're able to exchange materials on. But for the purpose of this call, I'm just going to choose a high-rise residential building and explain a little bit what this tool is about. So the first thing that is important to mention here is that this is by no means an final, very detailed lifecycle assessment of the project. This is really an informative tool that allows users to get a first understanding of how material choices impact the outcome of a project. And this is something that we heard from a lot of architectural offices is very useful in initial client conversations. So what you can do here is you automatically get the embodied carbon emissions in the upfront lifecycle stages, just A1 to A3, actually not all of the upfront, per meter squared of building, as well as how that compares to an average building in the UK in this specific example, and what that means in terms of global warming potential. So this global warming potential is, in a way, our translation of this footprint into what would it mean if every architect in the world was building high-rise residential buildings exactly like this one. And besides these basic metrics, you can see the list of materials that are selected, and then you can understand, where does most of the footprint come from. And then the interesting part really comes on this filter aspect, where you can open different components of the building and you can select all kinds of materials in the choices that we've pre-calculated here, so that you can see what can I do in order to get, for example, a building that is 2-degree compliant building, or something that is at 400 kilograms of CO2 per meter squared. The materials around this building, they span across all parts of the building. So you'll see that there's stuff of the foundation, so the substructure of the building, all the way down to what am I using on my wall finishes in terms of tiles and paint that I'm using, or what I'm using for my floor, the ceiling finishes, all of that. And the idea behind this, again, is to kind of play around with materials, click around on different options and understand what is achievable. But then also something that's very important is to put this in the perspective of the actual project you're working on. So an easy way to do that is you can enter the area of the building. You can enter what the projected occupancy rate would be. So how many people would actually be housed in this example, as well as how long you estimate this building will be up for, essentially serving that value. And you can also enter, for example, the estimated value of the project. The idea behind this is that, as I mentioned in the presentation earlier, it's important to think about the intensity of the use and how efficient the design is for the building. So that means that looking at the total carbon of the building, or even the total carbon per meter squared of area, is not always the best approach. So what we've done here is we've broken that down in a yearly carbon footprint, as well as in a per person carbon footprint, so that if you're designing a high-end residential building and you're going to house a lot less people because you're creating apartments that are much, much bigger than doing something of lower range, then you can actually see the impact of that type of design. So this is kind of the first part. Let's say you've had your first client meeting, you've sort of convinced them to some extent that it's worth thinking about materiality, and then you start working on a real project. So at that point, you would again go under Tools and click on My Projects. And under My Projects, you can essentially always go create a new project, enter whatever amount of information you would like. The only thing that is required from a calculation perspective is really just the area. And because we don't have all of the time here to explain how to create it from scratch, I'm just going to show an example of one of these projects. So this kind of example is essentially a residential building at the stage 1 of the design process. So something that still does not have almost any decisions locked in terms of design. So we want to start considering specific materials and seeing what can we do better. So in this tool, after you've defined the basic data points, you start selecting materials for each part of the building. So you can see here that I'm considering in my substructure a certain type of concrete, in my frame, again, concrete, and the floors, some type of timber, and the list goes on. And then if I go to this, what we call configurations table, you'll actually see the list of materials broken down in this table with actual quantities. So that means that I can open and see how much concrete am I using in my frame, how much timber am I using in my floors, as well as how much paint, for example, I'm using in the wall finishes. Now, the whole idea behind this kind of project is the tool I shared earlier is a very generic one. So it's something that is high level and assumes specific quantities for each part of the building, but it's obviously not representative of all of the typologies or design that you might create. So this is the opportunity to start entering, let's say, more real quantities in order to identify, okay, what is the actual footprint of this building? So you can enter materials, quantities, and then you get a life cycle assessment of the embodied carbon, which includes a lot of different metrics. So it includes the embodied carbon footprint, separated biogenic emissions, some circularity metrics, amount of fresh water that is being used to manufacture those materials, as well as different graphs that break down emissions per part of the building or per life cycle stage. So to understand whether there's a lot of emissions that come, for example, from the transportation impact of the materials because you ship them from very far away, or in the end of life because, for example, they're not recyclable or reusable. And this is on what I've just presented is kind of assuming we've specified, let's say, generic materials. So if I just go back to the example I'm seeing here, we are specifying paint, but that doesn't mean that it's a specific manufacturer for paint. So it's just saying chemical paint average data. And this is where I would link it to our actual library. So you see this search product button where you can start tapping into the library once you go into the specification process. So if I click that, you'll see all of the paint products that are listed on the platform. All of these are listed and specific to manufacturers. So you will see on each of these boxes, you see the name of the product as well as the name of the manufacturer. And then on this page, you already see part of the environmental assessment of the product. So usually this comes from what's called an environmental product declaration, which assesses the amount of carbon footprint as well as other things that the product creates during its manufacturing process. Now, the reason you would want to tap into the library is to actually find the real products that are applicable for your use cases. So that might mean that you want to filter the type of material that the paint is made from, or the manufacturing country of the paint to minimize transportation emissions, or things like the fire performance if it's reported, and also any sort of certifications that you might need in order, for example, to get the building-wide certification. Now, assuming you filtered out to the materials to the products you would like to compare, you can actually put them next to each other and really compare. So I can click on this compare button, and you'll see that on the top right, it starts adding to what we call my comparison cart. So I can add a few of these products on my cart, and then you'll see that on the cart, I can click it and then get a list that puts all of the data that we've collected and digitized for these products kind of next to each other so that it's really truly comparable. So if you're looking to get the product that has, for example, the lowest carbon footprint per meter squared of paint for these kind of products, you can directly go to the relevant row, compare this. You can, of course, always export these kind of reports in a PDF format and walk into a value engineering exercise. Yeah, and this, of course, goes towards the direction of having the ability to select products. And I'm realizing we're running a little bit out of time, so I'll just go to a product page to show the final part. So this is a product page of a manufacturer. You can find technical information on the left. You can find manufacturer's detail on the right, in the middle, and you can actually contact them for anything. As well as on the right, you'll find all of the environmental data, as well as certifications, data sheets, questionnaires that are answered by them. So this is really kind of the opportunity also for manufacturers, in case there's manufacturers on the call, to really become more transparent and give access to that kind of data to designers. Yes, so I've talked a lot and I realize that we are running a little bit out of time. So I would like to shift and say, first of all, very much for listening for this long. The platform is, as I said, we just showed a sneak peek, so please go on it, access it. It's free to create an account and browse around. You can really test it out, and you can, of course, reach out to us if there's anything that you need our help on. And with that, I would maybe switch to kind of a Q&A session, which I think I have on the, okay, there's quite a few questions. So I'll try to take the questions one by one as they came in the meeting. So is there a direct connection between material weight and embodied carbon impact? Good question. So it depends, I guess. So obviously more material of the same type usually means more emissions, of course. But as materials differ in their weight and their density, you might have a material that is much lower carbon per kilogram versus another one. So it's not a linear relationship for sure. And then the second question is, as an architect, I love your plain language, early stage approach, as opposed to many LCA products out there. Is there a target persona? Is your target persona a sustainability specialist or the plain architect looking to reduce the embodied carbon in their design? Or would sustainability specialists use your tool? This is a super important question. I'm not sure who exactly asked it, but our target persona is primarily non-specialists. So definitely architects and designers that do not need to become specialists. However, the data that we host on these products and the information and the tools we build can be used by everyone who is working in this space, and that does include sustainability consultants and sustainability specialists. Then some materials in your database have a negative embodied carbon value. Does that mean that biogenic carbon is included? Also a good question. So generally speaking, we are trying to follow the EN 15804 the A2 way of reporting embodied carbon. So when the biogenic carbon is separated from the fossil carbon in the EPD of the product, then you will find it reported separately on our material facts. However, the older EPDs might actually have those kind of data points together, in which case you might see some negative numbers, as you've mentioned. Then what life cycle stages does your system cover in the calculations? So if I can just very quickly maybe switch back here. So the tools side of things, so the projects that we showed, they really cover the whole life cycle. So if I go to the dashboard, you will see that we cover the A1 to A3 emissions, but we also cover transportation to site, installation, use of materials, and the end of life of products. And that most of that comes from EPDs of materials, but some of that calculation is actually calculated by us. So it's modeled taking into account the location of the products you've specified and the project. And then the next question is, how recycled content can be used as a KPI for reusable materials? So recycled content is essentially the upstream aspect of circularity. So this is a little bit of a complex question to really answer in a few seconds, but whoever it is that posted the question, we're happy to share some of the circularity metrics that we've developed and how recycled content, what kind of role recycled content plays into those. So you can always send us an email or a contact request to the website. And then I think Maham posted 3 questions. Can you benchmark only baseline buildings in the UK or other countries too? So on the embodied carbon tool that I shared, our benchmarks are currently still UK based, although you can adjust the industry benchmarks if you have other countries benchmark. Our research, we have researched benchmarks in different countries, but we are, I would say, most comfortable in the UK ones because we simply haven't researched other markets in a lot of detail yet. And then, what if the project is community-wide? Can we add multiple types of buildings under one dashboard to assess them together? Really good question. Something I wanted to mention is that our projects tool is actually extremely modular, and it almost happened by mistake for us. So it was initially intended to assess one building or one project. However, we've seen use cases, this kind of tool, let's say joke use cases where we estimate the embodied carbon of the Eiffel Tower, but also use cases where you can just work on a single assembly. So the examples you see here are just for an internal wall assembly, considering just 1 meter squared of brick wall, or there's also a fit out example. So the reason I'm showing the modularity of this is that, yes, to this question, you can basically use this tool however you like. So if you have the quantities and the materials for a community-wide project where you have the materials for each project, you can 100% put them together in one dashboard and understand the impacts. How do we calculate the baseline building? So we don't calculate the baselines of this embodied carbon tool. We basically look at what kind of research there is on average numbers of different types of buildings, specifically also in the UK, for example, from this organization that I mentioned called Leti, and then we use the numbers that they come up with by aggregating data from the industry. And then I think Leanna asked, are reclaimed materials, windows, kitchen, insulation, in terms of sustainability metrics, overall better than new ones? I'm not sure I fully understand the question, but okay, I do understand actually now. So I think the question is, when you reuse a material, is it actually better in terms of sustainability metrics, and can that actually be measured with our own tools? The question is yes, it's definitely better if you can reuse materials, because you avoid creating the emissions of manufacturing that material from scratch. Unfortunately, you cannot yet measure that with our tools. So we are creating currently a database of average data for reclaimed materials, seeing how much the impact is of a reclaimed window, for example, versus a new one. But it's something that is a working process. So it's definitely something that is in our pipeline, but not available yet. And then from Joe, I think, for materials that are not listed on the platform, where do the average figures come from, and are they location based? So it's true that some of the materials don't have environmental product declarations. So we usually estimate those numbers, and the way that we estimate it is we base it on the data that already exists on other materials. So essentially, we take environmental product declarations, split them by region and by material type, and then we average them to estimate the impact of a product that does not have that. And we always add a buffer, since we don't exactly know what the process is. So we try to be a little bit conservative. And then Anna Sofia, I think there was a question, was there an option to collaborate on a project in the app? Can I invite other designers to a project? Yes, absolutely. Basically, if you work in the same organization or under the same project, you can reach out to us and you can have multiple collaborations on the same project. And going back to the whole use case of these kind of projects, the reason they are modular and our intention is, if you're working on a specific assembly like the wall or the floor, you should focus on the part of your building that you're working on, and then you will have the ability to combine all of that data into a single project at the end, so that you can actually deliver the dashboard. And then the final question I see is from Chris and Mac, and how long will it be to get the client target definition module? That's also a good question. So I think Chris and Mac were referring to the tool here, where you can define your targets as a building owner. This is something we've had as a placeholder there on the platform for a while. We actually already have a developed tool, which is just not developed in our platform. So if anyone is interested, please reach out to us, and we can show how that works. In terms of when exactly we would implement it in the platform, I would say probably in the next couple of months, although we don't have a very, very specific date right now. And I think there's another question, and probably this is the last one we can get to, by Mirto. Is it possible to show the emissions of a material based on a specific unit, for example, insulation kilograms or CO2 per meter cubed? Again, this is one of the features that's coming very, very soon on our platform. So you will have the ability to select the unit on which you want to see the embodied carbon data, and whether that's meters squared or meters cubed or anything like that. We are currently working on a breakdown of those, or on a feature that you can select the unit and see everything on that unit. Okay. I think that's more or less the end. I guess I would take this opportunity to really thank everyone who joined. Super nice to have so much attendance, and of course, test out the application. Let us know what you think. You also have our emails, or you can reach out to us through the website. We're super feedback focused to hear what you think. Thank you very much. Thank you, everyone.